We've talked about the mole. We've calculated molar mass. So let's start doing something with that. So in this problem, we're going to take a given mass of urea and convert it to moles. And we're going to go back and use those dimensional analysis skills that we started at the very beginning of the term. So you're problem solving. What are we starting with? Where are we going? Well, you're given mass, and we want to convert to moles. So as soon as you see mass and moles, you should be thinking, molar mass. And then you think, okay, molar mass of what? You're given the chemical formula of the substance. It's urea. So you need to calculate the molar mass of that. And then remember what I said about molar mass. Yes, that is correct. But for calculation purposes, for using it in a calculation, that's the way you need to think of it. You need to split the mass and the moles. And whenever you calculate the molar mass, remember it's 60.056 grams equals 1 mole, not 60.056 moles equals 1 gram. That will cause lots of problems. Alright, so problem solving skills. Conversions. You list those. Well, we did that. That molar mass is a conversion. Okay. And then if you're ready to start, you kind of jump in. So what were we given? We were given the mass of urea. So let's start with that. And I'm going to write it just like I wrote the dimensional analysis problems we did before. I'm going to put it over 1 so I can separate my numerator and denominator. And I'm going to use parentheses just because I like parentheses. We started with mass. What do we want? Alright, we want moles. Oh yeah, remember, that's why we calculated the molar mass. Molar mass converts between mass and moles. And we're going to put that conversion in here somehow. Now we're going to go grams over moles or moles over grams. Look at what you have down below. You have units of grams. We don't want grams. We want moles. Therefore, you're putting the molar mass problem as 1 mole over 60.056 grams. Let's do a unit check. Okay, good. The grams cancels. And we're left with moles. That's good because that's what we want. And then divide. For significant figures, how many significant figures in the answer? 9.633 has 4. And the molar mass has more than 4. So 4 in our answer. This was a single step problem, so we should have a common sense check. Let's see. How do we know if that 0.1604 moles is reasonable? Well, what mass did I give you? Did I give you more or less than 60 grams? You're looking at it going, well, duh. Yeah, I gave you less than 60 grams. Should you have more or less than 1 mole in your answer? Gave you less than 60 grams, you have less than 1 mole, and at least it fits that. Hopefully, you got a glimpse of why we pushed on dimensional analysis at the very beginning of the term. That's because we were preparing you to do more complicated problems, and we're getting close to being able to do more complicated problems. They're dimensional analysis problems. They have more information in them than what we probably did before, but still, they're dimensional analysis problems. Follow the units.